Hello, my name is Lâm Đức Khải. I'm from University of Information Technology. Today I would like to present my paper named A Rothschild Guide, Hardware-Based Demo System. Here is the outline of my presentation. It includes 5 parts: introduction, background, proposed design architecture, results, and conclusion. First, I would like to introduce my research topic. My research topic focuses on the autonomous vehicle navigation. As we know, there are several techniques for autonomous vehicle navigation, such as GPS and image processing. The GPS is very convenient and very popular, but it's low accuracy. For the image processing, and currently now they focus on the software base. It means the processing based on the CPU. This technique is very easy to implement, but the speed is not high. Therefore, in this topic, we focus on image processing based on the hardware design. By this technique, it provides higher processing speed, so for real-time processing. In our system, the autonomous car navigation based on the land detections. So we use the hub transform algorithm for the road land detections. And the hub transform is the algorithm used in the image processing to find the dominant light. Dominant light go through the several pixels located in the light. In the hub transform algorithm, so we need to process every pixel located on the light by rotating light around each pixel with the step angles, and then a pair of radius and phi angular is determined for every step angle. So finally, the pair radius and phis appear the most, which presents for the expected light. Here, for example, if the lights go through 3 pixels, so this means that this is the expected light. This means the land light. Because the hub transform algorithms, we need to calculate the sine and cosine and also the multiplication operation. So it's very low processing. So therefore, in our system, we propose to use the coding algorithm to calculate the hub transform operations. We can convert the previous equations to these equations to calculate the radius and phi. Based on the coding, we see that if this angle is sufficient small, then we can remove the tan and cos operation from the equation. In here, in the table 1, so if we choose the phi is moved around 0.9 degrees, it means that the tan phi around 2 power of -6. So by this way, the code fee approximate 1. Therefore, we can remove the time fee and code fee from the equation, and we can achieve this equation. In these equations, you can see that 2 power of minus 6, so we can use the sitter operators. And now we only have the subtraction and addition operation, so we already remove the multiplications already. So by this way, so we can design the full hardware for the codec, and we apply the full hardware for the codec to calculate the hub transform for land detection. And in our system, after we detect the lines and we get the rotation, so based on the rotation angle, so we can determine the angle for the vehicle to navigate. For navigations, we apply the ACOMP steering geometries method. In this method, so this angle θ1 and θ2 are determined after we apply the hub transform. So if the θ1 larger than θ2, so the vehicle will turn left. If the θ1 smaller than θ2, the vehicle will turn right. If this 2 P1 equal θ2, so keep straight. If this the angle satisfy the equation, so the vehicle will also go straight. And here is our hardware design architectures. This is the full hardware design architectures. So the information captured from the cameras, and this go to the videos image processing chip to get the basic information from the cameras. And in our system, before go through the main image processing, so the picture go to the pre-image processing first, and then go to the main image processing. And after that, the output, this means the navigation output. For demonstration, we put to the processors for screen of VGA demonstration. So here is the pre-image processing modules. In the pre-image processing modules, so first the information from the cameras, and then they change the format of the visual information. They change to red, green, blue colors, and then turn to gray colors, and we put to the Gaussian filter to reduce the noise. After that, we put the information to the surveil operator to get the edge, detections. And after that, we split the image to 2 frames. 1 frame for the left lens and 1 frame for the right lens. And after that, we downsampled for faster processing. So after that, the information will go to the main image processing. In main image processing, as we discussed before, we apply the hub transform by on codec, because to cover every angles around the visuals, so we need to divide into three regions. The region 1, the radius from the x to their maximum radius is mean equals square of the x power of 2 plus the y power of 2. And in the region 2, the radius from the r mark to the 0, and the last one, the r from the 0 to the rx. So for the hardware of the image processing module, so we need three blocks for each step. This step 1 and step 2 and step 3. And we need the controls for the pipelines memory access, and this is the background play a role at the balloon voting. And in here for higher processing, we apply the pipeline, two-step pipeline. The one is the codec calculations, and one is the voting operations. And here is the results. The first, I would like to present the experiment results. We implement on the FPGAs, and here is the real image from the real landline, and this is the output of our system. We demonstrate on the screen, and here is our detections, and here is the navigation angle. So this is turn left. And here is the comparisons performance about the speed, latency and speed. And we compare our design with design in 4, 5, and 6. So the processing speed of our designs is larger than 4 and 5, but it slower than 6. But for the hardware ratio comparisons, so the memory bit and logic element. So about memory bit, so we use less than the hardware ratio of the 6. So for conclusions, so in our research topic, a full hardware architecture design for rockland detection is proposed, and Chauvel and hub transform algorithm are exploited for high land detection accuracies, and codec-based hub transform with the pipeline technique is applied for high processing. And here's some reference of my research topic. And thank you for your listening.